Hey everyone, I thought I'd just make a quick video about UPNP, Fluxnodes, IGMP and things that can go wrong, which seems to be quite a common issue for UPNP nodes. So this is a Fluxnode. So if we just grep through our LAN address, so that's the LAN address of our node. So this is also running some custom software that's a fork of some Python code that runs in IGMP Query. I've packaged this up so you can install it via apt. So what it's doing here, we can see that's our IP address, and this over here is OpenSense, which is a VM running on Proxmox. So here are the queries coming from the Flux node, and these are being responded to from OpenSense. So that's the IGMP v1 report. Now this is the mini UPnP daemon that actually responds to these, and I've found that it only responds to v1 reports. Now these are very important because if we go over to here to, this is on the Proxmox server, so if we watch the bridge, these are Linux bridges, so the one that we're interested in is VMBR2. So this is showing for this multicast group, this port is on that multicast group. So you can see there's a timer. So this starts at 300, which is 5 minutes, and counts down. So if the bridge doesn't get a multicast report in 5 minutes, it will cut traffic to that bridge, to that port, which means your UPnP will stop working. So you can see here as another reports come in, that timer is incremented back up again, so it just continuously increments. So if we run UPnP over here, I'm just going to pipe it into sed and delete the 15th line, just so you can't see my external IP. So you can see UPnP is working fine. So what we'll do now, this is a live node, so I'll just turn UPnP off for a bit, and I'll show you how it breaks and how to put it back on. So we'll just stop the query. Okay, so there'll be no more IGMP queries coming, which means there'll be no more reports getting sent. So if I just left this, this would time out to 0. As soon as that hits, UPnP will stop working. So what we'll do, we'll just hurry it up. Here we go. So I'll just delete that. So now if we watch the bridge, see how one port is now missing? That was just, we deleted that from the database. So if we run this UPnP command again, this will now time out. Since this port doesn't belong, isn't on the MDB, the database, see how UPnP is timed out. So now this is broken. So one way, the best way that I recommend for everyone getting started with this to fix it is to turn off snooping on your bridge. So you can see VMBR2, I've turned off snooping. So if we run this again, UPnP works. That's how simple it is. So what we're going to do now is I'm going to turn that back on again, and we are going to run UPnP again, and we can see it's broken. Okay, so what I'm going to do now is we're going to start the query again. If I could spell, there we go, cool. So that will send out another query in about a minute, I think. So we'll just wait for that to come through. And what will happen then is it'll get added back in on the bridge, and it will start forwarding traffic again, so that the OpenSense can now get the UPnP packets again, the multicast UPnP packets, because whenever I run this, it's sending multicast packets to this group, which right now the OpenSense is not getting because of snooping. So once the querier sends out packet again, which it takes a minute to kick in, that will start working again. So the same applies to, so there we go. So as soon as that packet came in, we're back in the multicast group. So if I run it again, we now have UPNP and everything will work magically. The exact same thing applies to ESXi VMware on their distributed switch. If you run snooping on that switch, the exact same thing will happen. You need to have a UPnP querier, and also, just as importantly, you need to have whatever your router is responding to those queries. Otherwise, shit breaks. Peace.